Lesson 5 of Chapter 7 deals with operations with radical expressions. The picture is taken in Minneapolis. It's of the Irene Hickson Whitney Bridge. The bridge was actually designed to look like a handshake. We'll start by simplifying some radical expressions. We're going to start with this one on the left. The square root of 32 x to the 8. If it helps, write them separately. Square root of 32 times the square root of x to the 8. Over here, we did this the other day. We realized that reduces right to x to the 4th, no problem. The root 32 is a little bit trickier. If it helps, factors of 32, 1 and 32, 2 and 16, 4 and 8. And when you look at this, you think, which pair gives me the largest perfect square? And it's 2 and 16. So I break this into root 2 times root 16. I realize the square root of 16 is 4. So I've got root 2 times 4 times x to the 4th. Of course, mathematicians like things in a certain order. They like things number, letter I if there is one, and then letters. Underneath the square root, we have numbers and then letters. So that's how your answers should look, in that sort of order. So our answers here will be number, letter, underneath the square root, number. Perfect. Over here, this time we've got the 4th root instead of the square root, but it's still the same. Break things into parts if it helps. And the 4th root of b to the 13. The 4th root of 16, I know that 2 times 2 times 2 times 2 is 16, so the 4th root of 16 is 2. This one I can simplify. 24 divided by 4 is 6, so I get a to the 6th. This last one is where the trick is again. I realize that 13 divided by 4, not friendly. So what I need to do is break this into, because it's a 4th degree, I need to break it into a multiple of 4 and whatever's left over. In this case, b to the 12 and b. Because 12 is a multiple of 4, that's what I break it into. The 4th root of b to the 12, if I bring this around, it's b cubed. 4th root of b to the 1st, not friendly, so it stays as is. Then I put it in this order. Number, letter, letter, underneath the square root, or in this case the 4th root, we put just the letter. My answer is 2, a to the 6th, b to the 3rd, times the 4th root of b. This time we're simplifying radicals that have fractions in them. In order to do this, we need to rationalize the denominator. That means we can't have any square roots in the denominator. For this one, it starts, if it helps, separate them out. You could rewrite this as the square root of x to the 6th over square root of x to the 7. On the top, simplifying, remember that's understood to be a 2. 6 divided by 2 is 3, so the top is x cubed. On the bottom, it doesn't work out so well. It's not so friendly. Because we know the index is a 2, we're going to break this into a multiple of 2 and whatever's left over. In this case, multiple of 2 is x to the 6th, and then we're just left over with 1. Square root of x to the 6th, again, bring that around. 6 divided by 2 is 3, so we get x cubed. Over here, we just get square root of x. Now most of you are probably realizing, wait a minute, x to the 3rd on top, x to the 3rd on bottom, those are going to cancel out. So that gives me 1 over the square root of x. But like I said before, square roots don't belong in the denominator. So what we do is we rationalize it. We multiply the top and bottom by the same thing. In this case, we're going to multiply top and bottom by the square root of x. Square root of x times square root of x gives me the square root of x squared. I realize these are just going to cancel each other out, so the bottom is just left with an x. On the top, 1 times the square root of x gives me the square root of x. There's nothing more I can do to simplify that, and I know that mathematically it's okay, to have a square root on the top. So my answer is root x over x. As we continue to simplify radical expressions, we get to this crazy monster of a problem. Keep things organized and you'll be fine. These numbers out in front, 5 and 3, you can just multiply those. 5 times 3 is 15. Put that out in front, no problem. Everything under the cube root can go together. Negative 12 times positive 18, that gives me a negative 216. A to the first and a squared gives me a cubed. B to the 4, b to the 2. When you multiply those, I get b to the 6. Then we're going to take things, if it helps to separate them out at this point, go ahead. Cube root of negative 216 times the cube root of a cubed times the cube root of b to the 6. Now, because I play I have who has, I'm well aware that 6 cubed is 216. And because this is a negative, negative 6 times negative 6 times negative 6 is still negative 216, so I'm good. 15 times negative 6. Over here, bring the 3 around, 3 divided by 3. They just cancel right out, it's an A. When I bring the 3 around, 6 divided by 3 is 2. So really I've got b squared. 15 times negative 6 is negative 90. A, b squared. Simplified. When we're adding and subtracting radical expressions, we need, in order to combine things, we need to have the same square root. The same thing underneath. Then we can combine them. Just like we both need an x or an x squared before you can combine like terms, we need the same number underneath that square root. Right now it looks like we can't do anything except we can simplify. Root 98 can be broken into root 2 times root 49. I know the square root of 49 is 7, so I've got 7 root 2. Root 32 we did earlier. Remember, root 2 times root 16. So that becomes 4 root 2. But remember, you have to multiply it by that negative 2, so that becomes negative 8 root 2. From here, 7 root 2 minus 8 root 2, if you want to think of it as 7x minus 8x, you quickly realize that that would just be negative x. So 7 root 2 minus 8 root 2 is negative 1 root 2, or negative root 2. Multiplying radicals gets a little tricky, but again, if you keep things organized, you'll be just fine. We've multiplied 2 sets of polynomials, so it's basically we're just foiling. Firsts. Well, 4 times 3 is 12. Root 3 times root 2 would be root 6. Outers. That's those two. 4 root 3 times a negative 6. Well, 4 times negative 6 is negative 24, and the root 3 comes along for the ride. Inners. Those two. 5 times 3 is 15. Root 2 times root 2 is root 4. And finally, lasts. We have 5 times negative 6, it's negative 30 times root 2. The last thing we're going to do is see if we can't simplify or combine like terms. The first one I've got root 6, root 3, root 4. Wait a minute. Root 4 is 2. So really we have 15 times 2, or 30. And then root 2, nothing else can be combined or simplified, so our answer is 12 root 6 minus 24 root 3 minus 30 root 2 plus 30. Combine what you can, simplify what you can, you'll do well. The last thing we're going to do is we're going to rationalize and simplify. We're dividing radicals. And this is just like when we divided complex numbers. If you remember how we sang, it was division is really great, multiply both by the conjugate. That's what we do here as well. We multiply both by the conjugate of the denominator. So here we have root 5 minus 1. The conjugate would be root 5 plus 1. So we multiply both top and bottom by root 5 plus 1. Root 5 plus 1. On the bottom, do what we just did. First, root 5 times root 5 is root 25, which we both know is 5. Outers would be 1 root 5. Inners would be negative 1 root 5. And last would be negative 1. You realize quickly these two are going to cancel each other out. So now we have 5 minus 1, which is 4. That's our denominator. We take that 4, put it in our denominator. Perfect. On the top, we don't have to FOIL, we just have to distribute. We take that 2 and distribute it to each term. So our top is 2 root 5. 2 times 1 is 2. So we're good. With most of you, if you stop here, I guess that would be all right. And I'd probably accept that as an answer. But some of you are going to realize we can reduce this. We can I heart algebra this. And we realize that the 2 and the 4 can be reduced down. So we have root 5. Over here, the 2 and the 4 again can be reduced down. So it's 1 over 2. I've just divided everything by 2 because they were all even. And so this is your simplified, perfect answer. Maybe you should celebrate with a shamrock shake. In case you haven't realized by now, the theme of the day was shakes. Here's your assignment, and we'll see you in class.